So we want to discuss divergence versus the surface integral of the vector field. And I'm actually looking at the vector field sideways, and you can see a bunch of vectors are basically going radially out. If you look at the full picture, you can see that everything is radially going out of the origin, basically. And then as you were looking at that here, the tilt over here kind of shows that there's more stuff getting out than the stuff that are coming in. So if I shrink this to an infinitesimal small ball, I see that basically divergence is positive. Every point acts as a source. Now, what divergence theorem says is that if I take all these sources and then sinks, and I find a total of those sources and sinks within a solid of the net source inside, or net divergence inside. So I can compute the net divergence by taking a triple integral, and then it's going to be equal to the surface integral, which gives me the mass getting out of the surface. That's one interpretation. Mass getting out of the net mass getting out of the surface is going to be equal to the triple integral of the divergence within. It's summing up all the sources and finding a net source, or net source minus divergence within the surface. And so that's one way. And then here is the radially going inward. And so you can see that basically things that are coming in are more than things that are getting out at a different point. And therefore, you have a divergence that is negative everywhere for this specific vector field. And so what you're expecting is that the surface integral of this vector field on the surface of this solid is going to be a negative value, because basically it's every point within it is acting like a sink. It destroys the mass. So things that are coming in, not all of them are getting out. So something is getting destructed within the surface.